Welcome back. Section 10.4 Areas and Lengths in Polar Coordinates. In this section, we learn to find the area of a region bounded by a curve defined by a polar equation. Let's recall area of this sector. Angle theta, this length from the origin r. Okay, so this is circle, radius r. Area of the sector here is r squared theta over 2. Okay. Now, using this, we are going to proceed. Now, suppose you are given a curve r equals f theta for theta between A and B. So, angle here is A, angle here is B. So, from A to B, you have a curve. You want to find this area. It's no longer a perfect circle, you see, sector. So what do? Consider a thin sector here. Okay, take a thin strip here, but it's actually a sector. So it meets at origin and radially moves out. This angle here is, let's call it delta theta. And the radius here, let it be f at theta, right? You're given this curve. So area is radius squared angle over 2. So notice this is an approximation because you have two different angles. You are choosing some angle in between f at that angle squared, so that there is an approximation. Okay. So how do you find the entire area here between this angle to this angle? Well, it is summation of areas of these small sectors, thin sectors. You may assume that you are taking the same small angle for every sector, same delta theta. All right. So you have chosen here n sectors. So you have n areas. You are adding them up. Required area is approximately this sum. Now, when you let n approach infinity, that is, you take more and more sectors, thinner and thinner sectors, then you get required area equal the limit. Well, limit of an infinite, infinite limit of sums, this is what we call integral. A to b f theta squared over 2, that becomes d theta. So that's your standard formula. Integral a to b r squared over 2 d theta, where r is f theta. Find the area. Here is an example of one petal from the 4 petal rows. R equals sine 2 theta. When you graph R equals sine 2 theta using methods we learned in our previous section, you will find it's a flower with 4 petals. Question is to find area of just one petal. How do I get this petal? Notice this petal comes from angle 0 radians to angle pi over 2. So one leaf for one petal is obtained from theta between 0 and pi over 2. So our required area is integral 0 to pi over 2 r squared over 2 d theta. R is sine 2 theta, so r squared is sine squared 2 theta over 2. Sine squared, we are using trigonometric identity, is 1 minus cosine twice of that angle. That's why you have a 4 over 2. There is a 2 already and one more division by 2 gives you a 4. Now this is straightforward integration. Integral of 1/4 is theta over 4 minus integral of cosine is sine. 4 theta gets me a division by 4, which is why I have a 16 here. Limits of integral are 0 to pi by 2. When I calculate, I get pi over 8 because sine of 2 pi is 0. And when angle is 0, both these expressions, both these values are 0. So answer is pi over 8. Likewise, arc length. Given a curve r equals f theta, x is r cosine theta, y is r sine theta. We have seen this before. Dx d theta, you use product rule, correct? Dy d theta, you use product rule. So, dx d theta squared plus dy d theta squared, you square these, use complete square formula, square minus 2 times here, plus r sine theta squared. That's the first line, the square. Likewise, the complete square here gives me the second line. So notice negative 2r dr d theta cosine theta sine theta, and you have a positive 2r dr d theta sine theta cosine theta. So these are going to be cancelled. These two get me dr d theta squared cosine squared plus sine squared. And here I get r squared sine squared theta cosine squared theta. So essentially this is 1, and likewise sine squared plus cosine squared is 1. I have r squared. So what's the point? This expression is dr d theta squared plus r squared. So the arc length is integral a to b root dx d theta squared plus dy d theta squared d theta. This is root dr d theta squared plus r squared d theta. Okay, so this is the formula for calculating the arc length. Here is an example. Set up an integration. Only set up. They are not asking us to find it. Find the arc length of one petal from the 4 petals. R equals sine 2 theta. The same example as before. Angle is between 0 and pi by 2. You are looking for dr d theta squared plus r squared. Dr d theta is 2 cosine 2 theta. R is sine 2 theta. Alright. So when I square it, simplify, proceed, I get 3 cosine squared 2 theta. Square root of that. That is it. They have asked us to set it up, not to evaluate. So that's your arc length. Now we will go over problems from web work in our next video. Until then, bye.